before we get started, hopefully you're digging out your note packet right now. You won't need a calculator today. Nothing we're going to do requires that today, but you need your note packet. Before we get started on Section 8.5, I want to take one last time to talk about the MCAs, reminding you that the schedule is all on the backboard back there in blue. And the juniors will be going to Mr. Mitchner's room, 4th hour, to take the test. You have to have a fully charged Chromebook. One of the rules that the MCAs has is that you can't have a cord coming from your calculator, your computer, while you're testing. So it has to be fully charged and ready to go. What else can I say about the MCAs? Oh, they've made a much bigger deal out of the fact this year, and I've got it on the front board there, that you can wear headphones. But the problem is, they're not the fancy headphones that most of you have, because you're not allowed to have headphones that have Bluetooth capability or any kind of wireless capability. They really are your parents' old big earphones that basically are just earphones. That's all they are, that would plug into the computer and let you hear it. I've only had one situation where I thought that really would have helped a student. I had a student that was testing that really was low ability in reading, and when they got to a problem that said the word inequality, they just didn't know what it was. And they called me over and they said, I can't read this word inequa. And as soon as I said inequality, they knew exactly what they were doing. So if you think that's going to help you, the school does not have enough of those old headphones for every junior to have one. But if you have your own and they do not have Bluetooth capability, you can bring those in and you can use that for the MCAs. So it's just something to think about. Sometimes it's kind of nice to have, a little pleasant voice talking in your ear while you're taking the test there. Today we're doing adding and subtracting rational expressions, and let me change the attendance one more time before I forget. But we already covered adding, and subtracting is just adding a negative. So we're going to do one example of subtraction. That's it. There's 3 big ones in the notes, but we're going to do one. And then we're going to move on to talking about one more topic in Section 8.5. So add and subtract rational expressions is where we're at. And we just didn't have enough time yesterday. I guess I could have gone over a subtraction problem, but then you wouldn't have had any work time. And it's kind of silly to spend a whole nother day just on subtraction, because if we just change it to adding a negative, it works exactly like the problems we did yesterday. So what is the difference of the 2 rational expressions in simplest form? State any restrictions on the variable. The first thing you want to do with these is change it to adding a negative. Oops, I'm not going to write the denominators down right now. When we were adding yesterday, our first step was always factor the denominator. When it's subtraction, change it to adding a negative. Because we've talked about this before. The most common mistake made in mathematics is right here. It's a little negative mistake. That's the most common mistake anybody makes. And so what we have to do is do that first, and then think, okay, now I need to factor my denominators. And x is going to come out of both of these. And that's in very basic factored form, so there's nothing else we can do besides factor out that greatest common monomial factor of x. The second one, we could take a 2 out of that one. So I guess I would change it to adding a negative step 1/2, Do that before you factor those denominators. Now what I have to do is figure out, well, what would I have if I went ahead and distributed that negative? And it would look like that. Now we do exactly what we did yesterday when we were adding. We think about, well, what's our LCD going to be? And once we know that LCD, we can come up with those domain restrictions. So there's still 3 parts we're going to look at for our LCD. Any numbers that are not part of a binomial, so they're not inside the parentheses. Well, this one has a 2 sitting there by itself, so we're going to have a 2. Then check for any variables that are not part of a set of parentheses. Well, this one has an x, so we're going to have that too. Then look at your binomial factors, your parentheses. You're going to need an x minus 2. But both of these are to the first power. So the highest power that we need is x minus 2 to the first. That's it. So now we can build them up. Now we can get the same denominator, a common denominator for both of these. And we take a peek and we realize, well, this has the x and it has the x minus 2. It's just missing a 2. So this one will need to be multiplied by a 2 in the numerator and the denominator. The other one has the 2 and it has the x minus 2. It's missing the x. So this one will need to be multiplied by an x on the top and the bottom. Might want to put parentheses around that negative x minus 2 so you remember to distribute that. Which is what we're going to do next. We're going to distribute in our numerators. So the first one will become 2x plus 4 over 2x, I forgot the 2 down there, times x minus 2. The second one will be negative x squared minus 2x over 2x times the quantity x minus 2. And now we can absolutely see that we've got a common denominator. So we can go ahead and do the adding. We'll have a negative x squared. 2x plus a negative 2x is 0, so that will be gone. So we have negative x squared plus 4 over 2x times the quantity x minus 2. Unless something in that numerator is factorable. And I can't see it right now because of that nasty negative in front of my x squared. So the first thing to do would be pull a negative 1 out of that. Whoa. There's my blue marker going crazy again. So now let's take a look at that one. X squared minus 4. Is that something we're supposed to know how to factor? It is, isn't it? That's a difference of 2 squares. So this will be negative 1 times the quantity x plus 2 times the quantity x minus 2. Is there anything that we can cancel? What can we take out of there? Yeah, so we do end up being able to do a little bit of canceling. So on the top we'll have a negative, and then in parentheses a little x plus 2. And on the bottom we'll have a 2x. That's what we can do there. And I looked up while I was doing this problem, and I realized I wrote the LCD in the domain slot, so we didn't get to talk about the domain. Let me go back up here. I just picked a slot. I put it in the wrong one. Give me a number that would be bad because 2x times the quantity x minus 2 is our denominator. 0 is out. That's because of this one. What's the other one? 2. So at most, we'll look at that and say, well, there's x's in 2 spots. We should get 2 numbers here. They could be repeats, but most of the time we'll get 2. So now our answer was, pardon me, allergy season. Negative of the quantity x plus 2 over 2x with domain restrictions. X can't be 0 and x can't be 2. So, like I said, I know they have two more problems down here. But subtracting is just adding a negative. So it would be really silly, big waste of time actually, to go through two more examples of that with you, and then you wouldn't have any work time. I'm not going to do that. Instead, we'll go on to the next topic, which at this point, if I look at the objectives and it says add and subtract fractions, I'd be thinking, hey, I'm done. I learned how to add, I learned how to subtract, but we have one more instance that we haven't seen. And those can look a little scary. When you see these examples that they have in here, you're like, wow, what are those things? Well, their name can also be a little scary too. They're called complex fractions. Now, they're not as bad as all that, and I know we see the word complex and we think, oh, that means hard. No, it just means more steps in math. That's all it means. So it's a rational expression that has a fraction as its numerator or its denominator, or maybe both. Maybe it has a fraction in the numerator and the denominator. Fraction and fraction, fraction and fraction. Look at this one. So we'd have to do some addition and some subtraction, and then we'd have to deal with the fact that those are fractions. Now, there are actually two ways to do these. We can simplify a complex fraction by multiplying by the numerator and denominator, well, actually the LCD of the numerator and the denominator. Now, you're going to do that next year. We save that for pre-calculus and for college algebra. The way we're going to do this is by doing skills we already know how to do. So what we're going to do is we're going to simplify the numerator and get just one fraction up there. Then we're going to simplify the denominator and get just one fraction down there. And then we know when you have a fraction within a fraction, you multiply by the reciprocal. And that'll be the last thing we do. So 3 steps, we'll get it. We're going to start right here. Simplifying a complex fraction. What is the simpler form of the complex fraction? I want you to notice that it doesn't say give domain restrictions or anything like that. And that's because there's enough to do with these problems that we don't want you to have to worry about giving them restrictions on the domain. So I'll try and remember to say this again when I give you the homework. You don't have to give me domain restrictions for complex fractions. Even if the instructions say to do that in the homework, don't bother with it. We're not going to test you on it. We want to test you on, can you get us one fraction with all these fractions that you see here? 3 steps. First step, put a big N, big capital N with a couple of little lines underneath it. We're going to get the numerator to be one fraction. Then we're going to do a capital D. We're going to get the denominator to be one fraction. And then we're going to put XR because we're going to multiply by the reciprocal. That doesn't look like a very good R. That's better. So those are the 3 steps. First, we get one fraction in the numerator. Then we get one fraction in the denominator. And then we multiply by the reciprocal. Let's get busy. That needs to be one fraction. So the first thing we should do is see, hey, is it addition? It is. Are the denominators factored? Yep, they're pretty basic. So we're going to go right to LCD. What would the least common denominator be for those 2 little fractions right there? X and Y. Yeah, we're going to need both of them. So that means the first one is going to need a Y on the top and the bottom. The second one has the Y, it's going to need an X. We go ahead and do the multiplication on the top, and that will give us 1Y plus X squared over XY. Now you could write x squared plus y if you want to, put them in alphabetical order. In fact, I'll do that because it would kind of drive me nuts that I have y before x. Step n, step 1 is done. We have one fraction in our numerator. Now we'll go to the denominator. The denominator looks like this. But if you work enough with fractions, you know that everything really should be a fraction when you're working with fractions. So we're not going to leave that as 1. We'll change that to 1 over 1. If we could, we would try to factor the denominator. But that's as basic as it's going to get, for goodness sake. So we go right to LCD. What would the least common denominator be for those two little fractions? 1y, yeah. So this one already has it. It doesn't need anything. This one needs a y on the top and the bottom. Well, that's just going to give us 1 plus 1y, which is y plus 1 over y. All right, we did step 1. We got one fraction for the numerator. We did step 2. We got one fraction for the denominator. Step 3, xr times the reciprocal. Now that means the first fraction, the numerator, we don't do anything with it. So we're going to write down x squared plus y over xy. But when you divide a fraction, you have to multiply by the reciprocal. So that means I have to go to my step D here, and I have to flip that one. And now we're multiplying. So there's a possibility there might be something here that we could cancel. So take a look. Is there anything in all of that mess that we could cancel? Or maybe we could factor something and then cancel? Do you see anything? Well, then let me give you a hint. There is one thing we can cancel. What's the one thing? Maya? Yep. This lone little awkward y right here can cancel with that one. But everything else has to stay. So when you multiply fractions, you do top times top. X squared plus y times 1, bless you, is x squared plus y. Bottom times bottom. Don't forget about your little x out in front here. And we get one more chance to think, gosh, can I factor that numerator to get something to cancel out? But we can't. X squared plus y. There's no common monomial factor. There's nothing else we can do. That problem is done. So 3 parts. Numerator, denominator, multiply by the reciprocal. Let's go to 4a. N D XR. All right. Well, this is nice. Look at this one. The numerator's x. We don't have to do anything with that. It's x. That's as simple as it gets. But we are going to have to do a little bit with that denominator. Now those two denominators, they're not factorable, but we can find an LCD pretty quick. What's our least common denominator for those two little buggers? Yep, have to take both pieces. So the first fraction is going to need a y on the top and the bottom. And the second one is going to need an x on the top and the bottom. And that will give us 1y over xy plus 1x over xy, which will be x plus y over xy. One fraction. So the numerator's done, the denominator's done, and all we have left is to multiply by the reciprocal of our denominator. So here was the numerator, but I want to see it as a fraction because I know I have to multiply by the reciprocal. So I'm just going to toss a 1 under there so we can see it as a fraction. Flip the denominator. And stop and check. Could there be something we can factor? Maybe something we can cancel without having to factor? Is there anything we can do to that one? What do you think? You see anything? Nope. Nothing on the top that's going to be multiplication that will cancel immediately with anything in the bottom. So top times top over bottom times bottom. And we take another look and say, well, there's nothing I could do there. That bottom has a plus. So the only way I could cancel that out is if I could factor the numerator and get x plus y. It's not going to happen. The numerator is too basic. So that one's done. Now those two are very similar to what you would see on the test. We're going to give you a very basic complex fraction on the test. But those of you that are going to go to pre-calculus and or college algebra next year, you need to see one that's a little tougher. And that is B. And I write too big, so I knew I had to cheat and give myself a little more space here. All right, you ready? This one's got more work. We can see that right away. N, D, XR. Well, my numerator, x minus 2 over x plus 2 over x plus 1. Well, it's addition. I don't have to change anything to adding a negative. I can't factor the denominators anymore, so I have to go right to finding an LCD. What would the least common denominator be for those two? X plus 1. Anything else? Yeah, we need them both. So that means the first one is going to need an x plus 1 on the top and the bottom. And the second one is going to need an x on the top and the bottom. So this one I'm going to put a middle step on because it's not as easy and basic as the other ones we did. So I have to do x plus 1 times the quantity x minus 2. Well, that's FOIL. We're going to have to do FOIL on that little bugger. First times first is x squared. Outside times outside is minus 2x. Inside times inside is plus 1x. So that'll be minus x. And then 1 times negative 2 is minus 2. Over x times the quantity x plus 1 plus 2x times the quantity x over x plus 1. And we can definitely see the common denominator here, and that tells us, hey, we can go ahead and do the addition on the top. So, negative x plus 2x is plus 1x minus 2. Unless we could cancel something. I wonder, is x squared plus x minus 2 factorable? Let's see. It's not a perfect square trinomial because negative 2 is not a perfect square. But maybe there are two numbers that multiply to negative 2 and add to 1. Are there? What are they? Oh, Cedar Home, we still can't cancel. We just wasted a step. No, we didn't. We're going to be glad we did that when we multiply by the reciprocal. We want those in factored form later on so we can see if anything will cancel out nice and easy. All right, I better separate this or it's going to start running into my work for the big D. Work for the big D. We've got 3 over x minus 1. Uh-oh, that's subtraction. I better change that to adding a negative. There it is. Well, my denominators are as factored as they're going to get. So it's time to go to the LCD already. What's the least common denominator for those two? We got to take them both. We do. So that means the first one is going to need an x plus 1 on the top and the bottom. And the second one is going to need an x minus 1 on the top and the bottom. And just be extra careful with that negative up there. That's where people make mistakes. So we'll distribute, and we'll get 3x plus 3 over the quantity x plus 1 times the quantity x minus 1 plus, distribute the negative, negative x plus 1 over x plus 1 times the quantity x minus 1. Whew. Common denominator right there. We can go ahead and do the adding across the top. 3x minus x, 2x. 3 plus 1, 4. Is the numerator factorable? What can we take out? Then let's do it. It'll make the next step easier. Whew. Numerator, done. Denominator, done. Now it's time to multiply by the reciprocal. So we're going to write down our numerator, simplified the way we had it as the last step up here. X minus 1 times the quantity x plus 2 over x times the quantity x plus 1. But I multiply by the reciprocal of the denominator. Got to flip it. Connor, start writing some stuff down, then you won't be so sleepy. Looks like so. And I think there's some canceling we can do. What do you want to cancel out? X plus 2's gone. What was the other one? Yeah. Anything else? But there's 2x minus 1's. Can't we cancel one of those? No. Remember, it has to be a match top and bottom. And those are both on the top. So we're just going to have to pull those two together here and say x minus 1 squared. So we have x minus 1 times x minus 1. What do we have left in the denominator? A 2 and an x, that's it. So pretty obviously, we simplified that as much as we possibly could, because there's nothing else we can cancel there. That is like an intro problem in pre-calculus and college algebra. In fact, we usually call it the prerequisites chapter. So it's something you have to be able to do in order to move on with the math that we do in the other two classes. Do you see how many more steps this had than the other two? You just have to be able to do the first two that we did. We would never put something like this on the test, because it would be, we'd probably have like 2 problems on the test, and that would be it. It takes a while to do this problem. So it's not that I don't believe you're all capable of this, because I do. Also know that there isn't one that's that difficult in your homework today. I tried to stick with problems that were like the first 2 examples that we did today. So that's what I need you working on the rest of our time here. Unless you still haven't taken the formative. Those of you that aren't juniors, you will have a study hall Monday and Tuesday while they're taking the MCAs. That is a great opportunity for you to get caught up on everything. Make sure you've taken the formative for 8-4. You've done all the homework for 8-4 and for 8-5. Tomorrow, you will have a video lesson and 8-6 day 1 to do. Oh, I didn't get it up there yet for day 2. And I took my microphone off. There it is. There's day 2.